Hey guys, welcome back to Math Tutoring to Go. Today we'll be reviewing the IM2 Unit 2 Quick Quiz Review. We'll be focusing on questions 3 and 4. Now, question 3 asks us to find the vertex, the stretch factor, and the equation of this function. So before we start with that, we have to firstly go over what exactly is a vertex. So a vertex of a parabola is the point at which the parabola makes its sharpest turn. You could also sometimes think about it as its absolute minimum or its absolute maximum. Now, another thing you will need to know is what exactly is a vertex form and how do we write an equation in vertex form? Okay, so the vertex form of a quadratic equation is just written as y is equal to a parentheses x minus h squared plus k. Okay, I know that was a lot, so let me go over how we're going to use the coordinates of the vertex to help us create the vertex form equation. Now, h is going to be found inside the parentheses and it's going to be added or subtracted from x. And just a little heads up, whatever is inside the parentheses, it does the opposite of what you think it's doing. So if it says minus 2, instead of going to the left 2, you're actually going to be going to the right 2. And vice versa, if it says plus 2, you're actually going to be going to the left 2 and not to the right 2. Now, our k is the constant term at the end of the equation. So whenever we have a vertex form equation, we are going to add in our k value, which is just the y value of the vertex coordinates at the end, or like outside of the parentheses. Now that we've talked about how to interpret the vertex form, let's talk about what exactly these variables mean. So y is simply the dependent variable of the quadratic function, which is what you've been using to write all your equations. Y is equal to blah blah. Now for the a variable, that just represents the coefficient which determines the parabola's shape and direction. So for example, if a is positive, the parabola will be going upwards, and if a is negative, it will open up downward. Now the x minus h in the parentheses, this is just the horizontal shift of the parabola, so the value of h determines the horizontal position of the vertex. So like I said, if it says minus 2, for example, we're going to be going 2 to the right. If it says plus 2, we're going to be going 2 to the left. Now, last but not least is k, and this just represents the vertical shift of the parabola, and this does exactly what you think it's supposed to do. So if the k value says plus 2, we're going to go up 2. If it says minus 2, we are going to go down 2. Now, just to give an example, we're going to look at the equation y is equal to 3 times x minus 2 squared plus 5. What this is telling us is that the value of a is 3, the h value is 2, the k value is 5, which means the vertex point of this parabola is 2, 5. Also, I don't know if I mentioned this earlier, but a also not only determines whether the parabola opens up upwards or downwards, but also if it has a stretch. So just to summarize, this equation is telling us that this function has a vertex at 2, 5, and it has a stretch of positive 3. Now that we have reviewed those things, let's move on to reviewing question 3. Now for question 3, we are being asked to find the vertex, the stretch factor, and the equation of this function using the graph. So the way we're going to go about this is we're going to look at the graph and find our vertex point. So our vertex point is our sharpest turning point per se, so I found that at 3, 4. And now that we know the coordinates of our vertex point, we can plug that into our equation. Y equals a parentheses x minus h squared plus k. So I plugged in 3 for h and 4 for k. Now this part is a little bit more complicated or tedious per se. And the next step is to find our stretch factor, which is a. So the way we're going to solve for a. Okay, so firstly, we're going to use our vertex form equation, which is of course the y equals a parentheses x minus h squared plus k, and then I'm just going to plug in my vertex coordinates for h and for k, which will get me this equation. After that, I'm just going to pick some random point from the graph that I like. So I'm gonna pick 4, 3. I know, what a coincidence. And so what I'm gonna do is I'm gonna plug in the x value of that coordinates to the x and the y values of that coordinates into the y, which will get me 3 is equal to a parentheses 4 minus 3 squared plus 4. Now I'm just going to solve algebraically for the a value. So this part is going to go by pretty quick. So if you need to pause the video, feel free to do so. So 4 minus 3 is 1. 1 squared is 1. We're going to subtract 4 from both sides. That will get us a -1. And that will get us a -1 is equal to a times 1. Divide both sides by 1 will get us a -1. So a is equal to -1. Now, if we plug in all our values into our equation, our final vertex form equation will read -1 parentheses x minus 3 close parentheses squared plus 4. So now we can write down that our vertex is 3, 4, our stretch factor is -1, and our final equation is y equals -1 parentheses x minus 3 squared plus 4. Okay, so for the second part of question 3, we're looking at finding the vertex. So what we're going to do is we're going to look at the table, and since we're looking at a quadratic function, we know that it's going to make a parabolic shape. And the vertex point helps us see that because the vertex point can either be the highest point on the graph, in which the parabola opens up downwards, or the lowest point on the graph where the parabola opens up upwards. So right now we're just gonna look at the y values on the table, and you can see how it goes from there's -2.5 on both sides, and it goes 0 on both sides, and then eventually, if we were to go a little bit more negative, we would also have 3.75 on both sides. But if you notice, the 1, -3 is really the only odd one out. So we know that is our vertex point because that would be where it begins to open up. Now that we have the vertex coordinates, we can plug that into our equation to help us find the stretch factor. So we're literally going to repeat the same process that we did earlier to find what the value of a is, to find the stretch factor. And as you know, the values we're going to plug in for y and x, we're just going to pick some random point on the graph. I'm going to choose 3, 0 to plug in. So I'm going to plug everything into my vertex form equation. So I'm plugging in the coordinates for the x and the y. So I'm going to plug in 1 and then -3. And then I'm going to pick my point. So I'm going to pick 3, 0. So I'm going to plug in 0 for the y value, 3 for the x value. And then from there, I'm going to solve algebraically. This part's going to go pretty fast, so feel free to pause it if you'd like. So 3 minus 1 is 2, and then we're going to add 3 on both sides. That's going to get us 3 is equal to a parentheses 4 because 2 squared is 4. Then we're just going to solve algebraically, which is 3 over 4. So that means our stretch factor is 3 over 4, and now it's time to write our final equation. So now that we have everything that we need to know to create our vertex form equation, we're just going to plug in all our values into our earlier equation. So our scale factor is 3 over 4, so we're going to plug that in for a. We know that our h value is 1, so we're going to plug that in for h, and our k value is -3, so we're going to plug that in as well. Also, key note, do not forget your y equals. If not, that is not an equation, so make sure it is y equals whatever the rest of it is. And that is our final equation for number 3. Alrighty, now we're on to question 4, and question 4 is asking us to graph this equation on the coordinate grid, and we have to include at least 2 points on each side of the line of symmetry. So we know that our line of symmetry is going to be located at our vertex point. And since we can see that this is a vertex form equation, we can easily find the coordinates to our vertex point. So we know that the coordinates to our vertex point is h, x, and so how we're going to find that is we're going to look at our equation, and we're going to look at the values of h and of x. So here h is -1 and k is -3. So we know that when h is in the parentheses, it does the opposite. So since it says -1, we know that the actual x value of our coordinate is +1, and then the y value is k, and k is just going to stay the same, so that's -3. So the coordinates of our vertex point are going to be 1, -3. So we can plot on the graph our first point, which is our vertex point, and we can plot 1, -3. Now we have to start plotting at least 2 other points on each side. So I'm just going to go in order, and I'm going to plug in 2 into this equation. And so what that is technically trying to find is what is our y value when our x value is equal to 2. So what we should get out is we should get out our x coordinate of 2, comma, some y value, which will tell us where on the coordinate, or like where on the graph that coordinate is located. So after plugging in 2 for our x, I got out -1 as our y value. So now I'm going to just plot the point 2, -1, and I'm just going to repeat this process with 3, and then I'm also going to do -2 and -3 just so that parabolic shape is a little bit more noticeable. With that math, I am going to do majority of it off screen, but feel free to go back to the example of where I plugged in 2 for the x to understand how to solve it algebraically. And just to restate how I did that, I plugged in 2 for x, so 2 minus 1 gets me to 1. 1 squared is 1. 1 times 2 is 2, and then 2 minus 3 is -1. So really all we're doing is following the rules of PEMDAS. So I ended up plugging in a 0 as an x value and -1 as an x value just because it helped create that parabolic shape a little bit faster compared to if I would have plugged in any other ones. And the way I can sort of see that is because since the vertex point shows also where there is a line of symmetry, I want to go off the points that will help me get a symmetrical parabola, if that makes sense. So I want to choose points that are across from one another. Now all that's left to do is to connect our points to finish up our graph, and we are done with question 4. Alrighty guys, that's it for today. Thank you guys so much for watching. Don't forget to like and subscribe so you never miss one of our uploads. If there are any still lingering questions or anything you guys are a little bit confused on, feel free to ask one of your teachers or request a tutor from Mu Alpha Theta. And that is it for the IM2 Unit 2 quick quiz review.